Hello, good evening, guys. I hope I'm audible and someone confirm.
Yeah, you're audible now.
Okay, so welcome to session 3. Today we'll be starting off with data cleaning, data pre-processing, and data transformation. Today's session will be conducted by Shriyasha Sadhu. So, Shriyasha, I think you can start with it.
Yeah, this is Nihal. Hey guys, good evening. I'll be taking a session today on basically data wrangling. I'll explain what it is. Let me just share my screen. I hope my audio is clear.
Yes.
I hope you can see my screen. Is it visible?
Yes.
Okay. It did not tell me anywhere that it's visible. Okay, good. Uh, so let me start with the session. Uh, Welcome guys. This is basically a session on data wrangling and data transformation. So what data wrangling is basically the whole process or pre-processing of data before you do any model training or use it for any application. The process of cleaning the data and making it fit for the use in machine learning is called data wrangling. So why is data wrangling important? I think you can see the points here. Basically, real world data is often messy, containing the missing values, inconsistent, irrelevant features. So what this means is when you collect data, you might not get complete data from everybody. So, for example, let's say you are taking information from someone in a form. There might be some fields which are optional. There might be some fields which are not applicable to everyone. So these are fields which will be left out or will be filled as not applicable. In which case, that information is basically cannot be used in machine learning because missing values often create problems for most of the pre-trained models or most of the libraries we use in Python do not like handling missing values. So all this must be done prior to using the data for our application. Next is unprocessed data, which is when we have some kind of data in which there is a lot of information which we might not need. So, for example, you have a lot of financial data in which you have a lot of missing information, or let's say you have information which are unreliable. So, there might be some kind of additions which are added in manually without which is not automatically informed. Like, for example, same forms example, maybe someone else you wanted to add in, so you did not fill the form, but you just added the details manually into, let's say, an Excel spreadsheet. So in which case your data is not consistent with the same data as the other fields in the Excel. Next, so the whole point of data wrangling is to make it into a format that is suitable for further analysis and machine learning. So data wrangling can be broken down into three main stages, which is data cleaning, data transformation, and data integration. Basically, data cleaning is where you modify the existing data and most of the times you're removing the unnecessary data or you're making it in a format that is suitable for further analysis. And next is data transformation, in which we are encoding, normalizing, and feature engineering. I'll explain these terms when we get to these topics. So for this data set, I have basically generated a synthetic data set, which is not anything available online, because most of the data set that is available online are already clean and they're already processed and ready to be used, because nobody would want to upload a unclean data set. So all the data in this data set is synthetic, which means it was generated using a code and it was basically meant for this purpose. Uh, I think the copy of this dataset will be shared with you guys through the website in a later time. But right now, I'll be using this dataset, in which basically the main features are basically employee details. So you have employee information like ID, name, age, salary, the join date, which is the day of work, the join work, department, education level, work experience, performance score, bonus, remote work, etc. Okay, all these features will basically be there are some of the other problems in some of these features which we will be cleaning and clearing out through data wrangling. So first, let me just load this data set. I have it in this data folder here. So basically the path is using a relative path dot slash data and slash data wrangling dataset is what I have given the name of the dataset. So these are basically the basic imports which we will be using through. And when you're running the code, I think you can check where all the which are the libraries which you're using. Mainly, we are using sklearn, NumPy, Pandas, and SciPy. And IMDlearn and datetime are specific to some scenarios, which I will explain further. So this is basically the dataset. It has been loaded in, and this is the starting head of the dataset. So if you can get to this stage, it means that the data has been loaded into your Jupyter notebook. Next is data cleaning. So what is data cleaning? Is when you, like I said, you are going to process the existing data into a form where you are basically polishing it, like by removing things which are unnecessary or formatting things which are not in a standardized format. So first is handling missing values. So like I said, missing values can occur when you're collecting form data. For example, is when people are not filling out forms which are or sections which are not which are optional or which are maybe irrelevant to that person. So these are reasons where you can have missing values. So some of the examples of missing values are sensor malfunctions, in which if you're using an IoT-based or sensors for gathering information, you might not have them functioning all the time, or there might be some kind of malfunctioning which will not give you the sensory input at that time. Human error, like I said, when we are adding all the data manually, there might be some kind of errors. Next is different data sources, when basically you're combining data from multiple different sources for your data set. That is when you might have a lot of problems, because you might not exactly line them up properly, or there might be some kind of features which are missing from the data set which are present in this. So you would have to decide on how to handle such scenarios. So first method of handling missing values is by deletion. So you just check which all fields are having a lot of missing values, and you can choose to drop the whole feature itself, or you can choose to drop the rows. This is usually a last ditch effort, in which you cannot fix the data which is already present, because most of the times when you delete a data set, you are basically, or delete the information from the data set, you're removing values which you do not want, because you would want as much information as possible for your machine to learn and generalize over. So this is the code for basically checking the missing values. I have just copied the data frame and data frame.isNull.sum. So basically what this does is it computes all the rows which have null values in them, and the sum of each row is given here. So as we can see right now in this synthetic data, basically the salary column and the work experience column have missing values. So how we deal with it is, what I actually told you was to drop the missing values, which is again not recommended if the data loss is high. For example, maybe this data set currently consists of 5,000 rows, so around 5,000 rows. So if we in 5,000 rows, if you're dropping 120 rows, it's not really affecting that highly. But for example, let's say we had maybe 900 rows or 1,000 rows which had some kind of missing value. You would want to maybe drop it or maybe not, depending on how important that feature is. So most of the time, if you delete rows, you're basically deleting information which is being used for training. But maybe a column is not important. For example, when you're taking information from a person, and let's say their phone number column, and most of them have decided to leave their phone numbers empty. That is not really relevant, because phone number is just used for you to contact that person, but there is not any kind of training which can be done from it. So in such a scenario, you can drop the whole column without affecting the performance of the model. And sometimes it might be better based on the performance might be better on depending on how irrelevant the data is. So I'm just not going to run this line, but drop NA is basically the code which is used to remove the empty data or the rows which have null values. Next method is through imputation. So what imputation is basically you're injecting a value based on some certain parameter, certain criteria. So imputation is basically you take some other value which would be most suitable for the in that missing row. So first is mean or median imputation, which is done for numerical data. So I think you all must know what mean and median are. So mean is basically the arithmetic mean, which is the average of all the data in that column. And the median is basically the middle elements or the middle valued elements. So let's say you have elements from 1 to 100, the median would be 50, whereas the average would be the sum of all the elements and divided by the number of elements. So this usually works well when the data is normally distributed. So for example, if you don't have data which is highly skewed or highly one-sided data, that time this data would be working better, and mainly numerical data, because if you have features such as, let's say, you're taking input like what is your department, what is your age, or what is your gender, what is your department, you cannot use mean or median imputation for that, because they are not numerical data and you cannot perform such mathematical operations on them. For that, we have mode imputation. Mode imputation is basically you're replacing it with the value which is occurring the most. So generally, let's say from this course, most of the students here enrolled, I'm assuming, belong to some of the computer related courses. So CSE, AI, or anything related to these courses. So when I am imputing data, I would basically most likely get computer science as the mode, in which case for any missing rows, the department will automatically be filled as computer science. Next is forward or backward fill, which is one other step that can be used. In which case, you assuming your data is organized or you're taking it, some kind of organization has been done. You are going to fill it based on the next row's value or the previous row's value, and this is mainly used in time series data. In which case, like I said, when doing an IoT project, you keep getting continuous sensory inputs. So that time it would be better to use this type of filling rather than using mean or median. So let's say you're measuring temperature of a person. So the average human body temperature is 97, right? But if you're continuously monitoring someone who has fever, so maybe let's say every hour you're monitoring them and their fever jumps up to 100, 101, 102, and there's suddenly missing value for an hour, and then you continue going with 101, 102. So the average, because most of the times our human body temperature is around 97, we are going to get as 97 or 98. But a person who's having fever suddenly will not drop his body temperature to 98 and suddenly jump back up to 101 in most cases. So these are scenarios in which forward and backward filling can be used or are generally used to solve this issue. Next is KNN imputation. KNN is a machine learning model with which you're basically checking the neighborhood. So what I'm saying is it is similar to forward and backward fill, but it's slightly different in which it is going to find the rows which have the most similar properties. So let's say I'm trying to fill the average marks or the average grade of a person. So I can maybe take everybody from the same age group, maybe from the same department, or maybe from the same subject. So these, based on these three criteria, I will basically filter out all the set of people who are basically similar to what all properties, other properties that are there for my row. And then based on the average value, or maybe depending on how you want to fill it out, you can take the most appropriate value and use that for filling it in. So right now for this data set, we'll basically be doing mean mode imputation, mean median imputation, and mode imputation. So for that, we are using something called a simple imputer, which is basically going to transform the data and it's going to search through your data, calculate the mean and fill it in. So imputer mean, it's simple imputer. Strategy is basically what we'll be using. It has basically these values: mean, median, most frequent, which is mode, and a constant value. So when you're using simple imputer, here we are using a mean value to fill out the salary column. I think if I showed you here, see here. So salary column, it's the first value itself is empty here. So when we are trying to find the salary of a person, we are going to use mean imputation. So maybe let's take these four example itself. In these five, it is going for filling out this missing value here. It is going to take the mean of these four values and then impute it here. So, and next is the KNN imputer, which we are using for again salary and work experience. Let me just run this code. So after imputing, basically what happens, it fills in all the missing values with this with through the strategy. And KNN imputer, like I said, you're going to be checking the neighborhood and filling it. So work experience, let's say. Work experience, this is a time period in which the how long they have worked for or work experience, in which average is generally going to work out well depending on if this data is based on a specific role or something like that. And KNN imputer is used so that it is going to compare all the fields. So right now we do not use mean imputation because let's see here we have different experience, so 23, 16, 20, and 1 year. So this is someone who's a fresher, so and highest education is high school, but this doesn't mean that both of them are the same. So when filling out person with this education level, so they have a master's degree, so when we are trying to fill this information, we are going to filter out people from the same department and with the same education level. It is automatically going to do this, so you guys do not have to manually search for these fields and do it. It is automatically going to be handled by the library itself. So it is going to find this department and education level, find people who have the same property. So maybe from the IT department with a master's level education, it's first going to find whoever is similar, and based on their values of work experience, it's going to fill it out. So after doing that, we are dropping duplicates maybe because usually when you fill out forms, when you leave out something and you fill the form again, you are going to have repeated values. So when you have all these values filled, it would be wise to drop your duplicate values just to ensure you do not have any repeated data, which is going to skew the model learning. So right now, after running this, if we are checking uh, the missing values in the code, we have no missing values, and we can see that these values have been already imputed. So this is because of the mean imputation. I think if you check over here, the value is not a number and work experience not a number, but over here it has basically found the average value and filled out for salary and work experience. Is everybody clear up till here?
Yes.
Okay, I heard only one yes. I'll just continue. If you have any doubt, please drop it in chat, and I can or just ask out here so I can answer you guys. So this was the basically the manual method to do it. Here we have used something called a simple imputer, which does the job for us. And dot fit transform is basically the method which is going to fit the data set using this imputer. What fitting is doing is it is taking what we want to find out. So for this salary column, it's going to find the mean value and then transform, in the sense it is going to perform this operation. So the operation performed is imputing. So it will inject the mean value into all the null valued rows in this column. Same for this fat transform. Another manual method or the old method without using simple imputer is basically using the pandas library itself. Basically, it has a column df of column dot fill na. Fill na is a method given by pandas to fill in the null values. And here we are using the same column dot median. So column dot median is basically performing the same class task as if we had median over here. It will be doing the same action over here as well. But this method of doing it is generally outdated, and the code gives you a future warning, which means this code is going to be removed. So is going better not use it and use this imputer method because it's much more simpler and easier to use. But this is also right now a valid method, but it would not work in the future. Next is handling outliers. So what are outliers? Basically, outliers are values which are extremely far away from your mean or median value in the table. So let's say you're writing your CGPA, in which case most of the times our CGPA is going to be between 1 and 10. And suddenly, let's say someone has by mistake entered, instead of saying 8.5 as your CGPA. Someone has forgotten the point. I've just added as 85 CGPA. So this will be a problem because it is an outlier in which it's an extreme value, which is most likely not true. There are cases in which this value is true, but in many scenarios, this is basically some kind of error which happens, or maybe, like I said, in that example, when your sensor is not working, most of the times the signal is just zero. In which case, suddenly the sensor cannot go from giving some kind of reading to zero all of a sudden unless there is some kind of issue. So these are scenarios in which there are outliers in the data and you would want to remove them. So these are the common methods of finding outliers. First is the Z-score method. Basically, what Z-score is a mathematical term in which you are comparing the current value with the mean value and the standard deviation. So what we are doing is subtracting the mean value. When you subtract the mean value, you are going to basically get how far it is from the mean. And when you divide it with the standard deviation, you are going to get how far away it is from the mean. So that is basically what Z-score is. So how far away a current value is from the mean or median value of the overall column. So if it is very far from the median, it is most likely that the data is highly skewed or that it is an outlier. So what is generally used is uh, Z-score, which is less than 3, we're going to keep it. So any Z-score which is more than 3, we're not going to keep it. So what Z-score is, like I said, standard deviation. So let's say your values are from 1 to 10 for CGPA. So and your, let's say your average CGPA is 8. And suddenly if your GPA is around 9, so 9 minus 8 divided by, let's say, standard deviation is around let's say 0.8. So 1 divided by zero point 0.8 is going to be a it's going to be a fractional value. But when I took the example of that 85 CGPA, so 85 minus 8 is basically going to give you what? 77. 77 divided by zero point 0.8 is going to give you something what? Around 100. So which is a very strong outlier. So for your value, it's a very strong outlier and you would not want such entries. So what we're doing here is basically assigning wherever the Z-score is less than 3, we are basically assigning that to as our data frame. Next is using the interquartile range. What interquartile range is basically, you're dividing your data set into 4 quartiles. Basically, the first percentile based on the percentile. So let's say your values are from 1 to 10, but we are not using actually dividing by 4. It's not 10 by 4, so 2.5, 2.5, 2.5. It's not like that. It's basically based on the data that is there. So let's say we are using median. So let's say the average or the median GPA is somewhere around, let's say, 8 GPA. So the majority of the students are lying around 8 GPA. In which case, the strength is, if you divide it based on the number 2.5, 0 to 2.5 is not really going to have that many students. So it's not a fair balance. So what you're trying to do is balance all the 4 divisions based on the number of people in each division. So you're trying to, that is what interquartile range is. And that is what the quartiles are, sorry. Interquartile range is basically the difference between the highest percentile and the lowest percentile. So let's say if you split, let's say 100 students, so 25 students are lying between, let's say 0 to 6, 25 students have between 6 and 7, 25 students have between 7 and 8, and the remaining 25 students have between 8 and 10. So based on that, it is going to find the difference between the first quartile, which is 0 to 25, 0 to 6 GPA, and the highest quartile, which is 8 to 10 GPA. So when you do this, you're going to get a value. So let's say 8 minus 6. So basically 2 GPA is your interquartile range, and whatever is 2, over here we are using 1.5 times. Yes. Yes, tell me. Did someone want to ask something? Okay, I'll continue. You can basically check out what interquartile range is. It's not that complicated. So we are finding the quantile using this function, which is given by the pandas library. So between this 25th percentile and the 75th percentile, whatever is the value, you're comparing that with the salary overall salary value, and you're removing those which are too high or too low. And based on doing that operation, most of the times your data, in this case, the data has not changed as much because there was not that much deviation. Uh, that is the next method. So any doubts in this, in handling outliers? Okay. I guess if no one has any doubts, I will continue. Next is standardizing data formats. So when we have data in an unorganized manner, or we are doing manually inputting data, we might have different ways of filling in this data. So for example, date is the most common thing which comes in mind, in which people have different ways to write date, or maybe your format is between the Indian calendar, which is basically day, month, and year, days, months, and years, and what the US uses, which is month, days, and year. These are different data formats which can cause problems when you're trying to have a standardized data set, in which case you need to make it into a same all the data across the column is in the same format. So basically what that is what standardization is. You ensure consistency, facilitate comparison. So when you have two different dates, if they're in the same format, you can basically compare the days easily. Whereas, let's say you're comparing an Indian date with the US date format, you might not realize which one is the day and which is the month, and if it is actually the same or not. So it would be better to have your data in the same format so that it's easier for the model to learn and for you to understand the differences as well. Next is reduces error. Like I said, if you have it in the same format, you will not misunderstand the data. And by doing all this, you're basically improving the data quality. So the common things that are required to be standardized is date and time. So date and time will have different formats, but what we are using is .to date time format feature, in which you're basically using the computer format, which is year. First is year, next is month, next is date. So it is trying to format everything, and it is comparing. And if it encounters an error, it is basically this is a different what the function can do when it encounters an error. Let me just bring it up for you guys. So here, so if there's an error, it will basically first raise it as an exception, or coerce is basically fill it out as not a valid time, and or else it will just throw an error. Here we are just giving coerce because we do not want any errors, and if a date is not there, we can deal with it later, and we're converting it to a datetime object. So this is what models are made to understand. So when we are taking form input, date can probably is usually given as a string. So when we run it as a string, it is not really a date, it will be treated as a string. So by doing this, we're telling the code that it is some kind of date and time. So it should treat it as such, and which is commonly used for a time series in which the date is very important. Next is numeric data standardization. So in this example, I have taken something called a bonus over here. So in this bonus column is basically the amount of money they get. So salary and bonus. So in these fields, let's say somebody has entered the dollar amount or the pound or the rupee amount. So if somebody has added these symbols, or they've added RS, or they have added something like that while entering the amount of salary they have made or the bonus they got, it is going to be inconsistent because all these values are basically numbers, and having these symbols is basically going to convert all these into a string, because there are values which are non-numbers, and these are symbols which cannot be read as strings. This whole column will be considered as a string, which is not what we want, because it is still something in which we can perform mean, median, or numerical operations. So we want this data to be considered as a number. So what we are doing here is dot replace. So basically this is a regular expression or a function in which in this column we are replacing anything that is a dollar or anything that is a pound symbol with nothing. Basically we are making it as an empty string. So all the symbols will be removed, and that is what this code is for. And as type int, what it's doing is converting that field into an integer. So it will be considered as a number format and it will be applied on all the data. So what the errors can occur is this code may not work if all the data cannot be converted to an integer. So if there is still some kind of strings left behind, when you run this code, it will basically tell you that, okay, it's not converting it to a string because some data which is in the dataset is not able to be formatted as an integer. And that is what we are doing for all the columns here. So salary, bonus, as we can see, after doing this function, it is going to convert into an integer. Over here, we can see it is basically right now a floating point number in which we are having decimals here. But once we run the as type int, it is basically converting it to an integer and there is no floating point numbers left. So we have applied that for all the things which we want to be as a numerical column. So salary is a numerical column, work experience is a numerical column, a bonus is a numerical column. So we have applied all this and made this as integers. Next is categorical various standardization, which we have done basically on this name over here. So what we have done is names can have maybe some kind of title or maybe you have there's some kind of issues in casing. Let's say when you're typing your full name, you're going maybe your first letter is not capitalized, or maybe there is some kind the second letter is an initial, something like that, or there's empty spaces before and after when you're typing in your name. So this is basically inconsistent or it's like useless data. So when you type your name, maybe you just hit the space bar twice and after typing a name. So these are all, or there is a new line character. When you press enter, usually there's a new line character. So you want to remove all this. So for the name field, what we have done is we have taken the column and we have applied the str. Str is the string function and we are applying strip. What strip does is it removes the extra spaces that are there in the string field in the starting and ending. Next is the title, in which case you're basically capitalizing the first letter. So all the names we're going to have the same format in which the first letter is capitalized when we read the name column. Is everyone clear with this?
I have a doubt.
Yes.
Oh, what does regex equal to true mean? It's a parameter in the bonus.
Okay, so when we are running this as a the dot replace function takes a regular expression. So regular expression is basically some kind of a string value. We do not need to use it in such a way also. So maybe let's say I just want to give it as slash a dollar here, and in which case we would not require this. But uh, here we will just be replacing all the dollars and then we're converting it to a string. Whereas if we are using regular expression is something which is specifically made for string comparisons. So regular expressions are some kind, it's the type of code, it's not a code per se, but it's a format in which you can filter out the strings. So maybe you will learn this in your future semesters or you can look it up, but it's a format in which you can basically give certain conditions on how a string would be. So let's say A to Z is basically all the alphabets or it has certain formats, in which case here we are basically just taking a single character. So in that regular expression basically giving it as R before giving a string in Python is considered as a regular expression, in which case he'll take, okay, there's a dollar and there's a pound which I must search for, and I should replace it with an empty character. So that is what regular expressions do. It is mainly for string comparisons. Are we clear on that?
Yes, I'm clear. Thank you.
Yeah, no problem. Okay, any other questions before we go on to pre-processing? Okay, I'll continue then. Next is encoding of categorical variables. So what is encoding? Basically, encoding is when you take data of a different format and you're converting it to uh, another format. So here we are basically converting it into numbers because machine learning model require numerical data. When you tell a machine learning model, give it a string, it is not really able to process that string as such. It is mainly meant to process numbers, uh, basically just like all computers are. And so what we do is convert categorical values into numbers. So in this data, we have this department field and this education level field, both of which are categorical, which means they have IT, HR, finance, all of these are categorical variables in which you can divide them into categories. These are not understood by most of the machine learning models because they are not meant to process text. They are meant to process numbers. So to avoid any issues when handling machine learning models with such data, we perform encoding. So there are mainly two types of encoding. First is label encoding, in which case we are basically giving a number to each of the different categories in this field. So, for example, IT gets a number. Let's say you're starting from zero. So maybe IT is zero, HR is one, finance is two, and then IT again. So since we already have IT, it is zero again. HR is one. So basically, this is how we are going to assign the categories as numbers, which are easier to process for machine learning models. So for that, we are using something called a label encoder. So when we're using label encoder, this is the basically a complicated example, basically to show you guys. This is the line of code which will only be required for you to convert. So label encoder dot fit transform, and like we use in the if someone would ask something. Okay. Uh, dot fit transform. As we saw on the simple imputer, what we are doing here is basically something similar, where we are taking all the values in education level. So in this case would be masters, high school, bachelors, PhD is also there. I think PhD is also here. Yeah, PhD is also the other level. It is going to take all the unique values in from this, and it's going to fit them with numbers. So it's giving a unique number to all of them and transforming the data. So this column TF of education level is going to be transformed with these values instead of the categorical values. Basically, instead of master's high school, is going to transform them into the numbers. So this is the code I have just done just so that I can print out. So dot fit is just creating the values, and fit transform is really fitting the values and transforming the data. So I have just done this. You can basically copy paste for your own data set without much of thinking much about it. I'll just explain slightly. Dot zip is a Python function in which you are combining two sets of lists, basically creating key value pairs. And the dictionary is basically when we are creating it as a dictionary. So education level dot unique. So we're extracting all the unique categories in this field, and when we are fitting and transforming, we are going to bring out which all are unique in this as well. So what this code is basically doing is this is mapping the number which is assigned by the label encoder to the category in this existing field. And dot transform is basically transforming again. Same thing I'm doing with the department as well. Next is when wait before going to the next one, this is basically the output. So you're going to get education level mapping. So I've just printed out the table here. You don't need to worry too much about this. You don't need to actually do this for the code to work. Like I said, this one line of code is enough. The rest are basically just for the current explanation over here. So we are basically assigning the different encoded values here. So encoded value for masters is 2, high school is 1, bachelor is 0, and PhD is 3. So this is basically assigning in the order in which they have occurred. So these are different values in this going alphabetical. These are the values. And for the department, IT, HR, finance, marketing, and finance, we are basically giving categorical values. I think there was a problem with the data. I think that is why there is repeat over here. Uh, Ignore that. That should not be there. Apart from that, next is one hot encoding. what one-hot encoding is commonly used for binary data, in which case it basically just creates a value for creating telling whether something is true or false. So, for example, in this data set, we have something called remote work, which is not exactly categorical, but it could have been. So, do you opt in for remote work? Yes or no? So, in this case, we have basically taken it as a binary input, but in forms, you generally has yes or no, or true or false, something like that. So, maybe all ones would be true and zero would be false. In which case, you would want to transform it into this existing format where you have zeros and ones. So, for that, we are going to use one hot encoding. In which case, it's a pandas function called get dummies. You're not going to apply it directly on the data frame itself. So you're going to call this function and pass the data frame and the column on which you want to apply. So for remote work, and drop first is equal to is basically just going to drop the existing column and then replace it with the new column. So when I run this code, I think here remote work is removed and we are basically removing converting it to a boolean value of true or false, which will be treated as 0 and 1 when you are running it in a machine learning model. So remote work one is basically is remote work as one? Is it true or false? So maybe let me run it for another column and show it to you guys. Let's say I do it for department now. So when I run it for department, since we have already encoded the department fields, basically, so is department one true? So basically, is this department, is it one? Is it true or false? Is it the department is two, true or false? So it's basically comparing it like that. You do not generally do this for fields which have too many categories because again, we are adding unnecessary columns to the data because these many columns are not required for us to represent in which case label encoder is preferred. But maybe when you have basically a yes no question, these are the cases in which one hot encoding is preferred. So any questions here? Any questions so far?
No questions.
Okay, let me continue. Next is handling imbalanced data sets. So what is imbalanced data set is when you have some kind of field in which you're comparing or some kind of value and the data you have is not matching that value. So for example, if you're comparing the average salaries, let's say, so basically this is what you would use ML models for. So maybe you want to find the average salary of a column based on their department, let's say, or maybe based on their oh wait, let me just change this back to remote work. So maybe you want to find the average value of the salary of people who are opted for remote work and who are not opted for remote work. So those who are working from office and those who are working from home, basically, you want to compare the average salaries. In which case you have data which is imbalanced. So the number of people who are working from office right now, maybe during COVID, was very low compared to the number of people who are actually working from office. In which case your data is highly skewed because you do not know enough about the people who are working from office or what are the scenarios they're in to compare them with people who are working from home, because that was a special time in which most people were working from home and were affected badly, but you did not have enough data to compare them both. So these are the type of scenarios in which you are going to have imbalanced data, in which the data of one class, in which case is remote work true and false, basically one is more than the other. So to handle these methods, there are basically three main methods: resampling, in which you're basically going to artificially create data. So oversampling a minority class or undersampling a majority class. So let me explain. What oversampling is, basically it takes the class which has less data. So for example, in this COVID example I took, more people had opted for a work from home, but very few were actually working on premises. So you would take the less people who are working from office, find the average value of each of them, and basically create fake data for matching an account. So let's say you have 100 people who are working from home and 20 people who are working from office. You would make that 20 into 100 by artificially creating based on the mean, median, or different parameters, or whatever parameters you require. Maybe KNN imputation would be well suited here, because you're going to find the neighboring parameters, and based on that you're creating fake data. The other one is undersampling. Undersampling is not that commonly used because it requires deleting data. So with the same example where you had 100 people and 20 people in these two categories, you would delete the column rows in the 100 to make it a 20 to match it with this. In this case, you are basically losing out on data. So this is actual data which we have actually collected, and we know it is true. And unlike oversampling, in which it's artificial data, so you would not want to delete data that you have actually collected, because that has more value than the fake data. So oversampling is generally done uh, to norm in this process. Or if maybe when you have too much data which cannot be handled by the model. In that is the case in which you can go to undersampling, or when you have enough classes, maybe you have 100, and one class just has 1,000 for no apparent reason. That 1,000 you can maybe filter out the 100 unique ones, or maybe 100 diverse values, and match it so that all of them are still 100. In that case, it would be easier to downsize than to oversample. Next is synthetic data generation using techniques like SMOT. SMOT, basically what it does is, based on each class's features, which I said, using KNN, or based on different features of the class, it's going to generate the values. So oversampling, the majority of it, maybe you're just duplicating the values. That is what is commonly done. And synthetic data is done using SMOT. It is also an oversampling technique. Like here it says synthetic minority oversampling technique. It is an oversampling in which it actually does these computations, whereas in general oversampling, you're just duplicating the values to synthetically generate and balance the classes. Next is algorithmic approaches, in which in your machine learning model itself, you are going to change the model to work in such a way that even if it has less data, it is going to work with it. So what this does is, you're handling it in the model itself, but since we are not covering the models right now, this is for the data itself, we will be using SMOT here. And for SMOT, basically, it is similar to a model in which you need the data to be formatted in a specific way. Here, SMOT analysis cannot work with categorical values and cannot work with string values or object values according to the code. So what we are doing is, first, and date time. So we had converted the field into a date time, but join date into a date time value. But SMOT, it does not work with any of such object classes. So just for SMOT analysis, I'm basically converting it into an integer. So I'm just changing it to years at the company instead of the join date. So what we are doing is taking the current time, that is what the date time library was for, the current time minus the join date, and then we are dividing it by the number of years. So we just get the number of years the person has worked at the company for. Next, and then we are dropping the join date column. So now this is basically a numerical column. Next is ID and name. So when we are generating data using SMOT, these things such as name, ID, they're helpful for us in identifying which row we are talking about, but they're not really useful in terms of the data they're actually adding. So I don't need to know a person's name is Hank, for example, to be able to predict based on these parameters, because their name is not really affecting, or it shouldn't be affecting, the salary they're getting. Next is a performance score, is what we are predicting or we are generating for right now. So based on this performance score, this is the target variable. So we're dropping everything but the performance score and keeping the performance score as the target variable. So the target variable is basically based on which we are creating this performing this SMOT analysis. So we're running this. Just leave this as is, sampling strategy auto and random state 42. Random state is basically used to be able to replicate and get the same results, even though it is a randomization process. And sampling strategy is auto, basically based on the type of data available. It will automatically select the best strategy to replicate or oversample the data. So when we do this smooth analysis, wait a minute. Here, when we run this code, basically before running smooth analysis for different performance score, the performance score was basically the rating, so 1 to 5. These are the values that were available. So we can see that the number of rows available for the different performance scores are varying highly. But after performance mode analysis, basically that value counts is giving the number of values for each of these categories, and we are seeing that everything is 1415, so it's uniform. So you have the same amount of data for all these different classes. So that is where we use SWOT analysis and basically how we handle imbalanced data sets. Any questions, guys?
I have a question.
Yeah,
I may be having two. Let me go with the first one. Um, so resampling is when you just copy the previous data, whereas synthetic data generation is when you generate an artificial
correct.
data.
Correct.
Okay. Okay.
So basically here what you're doing is oversampling. You are taking existing data, maybe you're taking this column. So you want people with performance score 5. So you just take these exact values, you're just copy pasting them multiple times. So that will technically do the job for you. Whereas in Smart, you're basically taking these parameters into account. So maybe you're seeing, okay, which department, which education level, and based on that, what are the performance scores they had. Based on that, it will automatically assign the value or automatically generate these values based on the different parameters they had for existing data. So all the people who have had performance score of 5, let's say, have had work experience between 20 to 25. That is what the automatically it has figured out. So it is going to generate data which has work experience between 20 to 25. It need not be 23 always. Something like that. Is it clear?
Okay. And I have a second question incoming.
Yeah.
SMOT analysis uses only numbers. We cannot input strings.
Hmm. Yeah.
So before using SMOT analysis, we would preferably go for label encoding.
Hmm. Correct.
Y- y- Yeah, okay, fine. Thank you.
Yes, no problem. And again, maybe you can add these columns back in after performing the SMOT analysis. So you do not need to, drop them for permanently. You can maybe generate random names and just or random IDs. But most of the times when you're actually doing machine learning models, these values actually have no real meaning. So you would generally drop them. So in this case, when you perform SMOT also, after dropping them, you're not really losing out on anything unless you're actually running machine learning models. So if you're actually just generating data just to look at it or maybe have personal information on people, you would not use smart analysis. This is mainly meant for machine learning applications in which you're training on this data. So you would not want to use smart analysis on your, let's say, student database of our college and just create a bunch of fake students and have them in our data. That is not what we are. That's not what this is for. Mainly for machine learning when we want to train and we don't have sufficient data. Next is feature selection. So what feature selection is, as I was saying, not all columns are equally important when we are performing machine learning analysis, machine learning, creating and training machine learning models. So some columns add more value than the others. So these are what we call as weights in machine learning, in which it is going to assign weights to each of these parameters, and based on that weight, it is going to learn something. In which case, having things like name, ID are basically going to add unnecessary complications to the model. So no, generally, you would think that your name should not matter on how much performance you are giving. So that's not really, there's no really pattern over there. Maybe your department and your work experience is directly like related to your performance, but your name doesn't really do much. So in that case, by keeping the name in the training, you're making the model be more complicated. So you're basically trying making the model analyze what is the correlation between the name and performance, In most of the cases, you're not going to find any direct correlation, but it will just create a lot of time. It will take a lot of time for the machine learning model to train on the data when you have features like this, which are not really relevant. So this is where you perform feature selection. So removing based on variance thresholding. So what variance thresholding is, whichever features do not vary a lot, those are features which can be removed. So maybe let's say we are comparing the performance of everybody from the same department, in which case everybody would have the same department value. Over here it's different, but you would just have it as 33333. So in that case, you would not really care about the department value, and you would not want to use this information, give this information to the model, because it's unnecessary, because the value is not changing whatsoever. So in that case, you would not want to keep this column. And when you perform variance thresholding, it's going to check if the variance is actually lesser. So here what we are doing is basically we are setting a variance threshold, and whatever is less than this variance threshold, we are keeping it, and whatever is more than this variance, so something which is varying a lot, we're going to keep it, and something that is not varying too much, we are just going to drop that feature. Are we clear? Basically what you do is you calculate the threshold, you're giving it a threshold, and so this is basically just Python code. It's not really something specific to pandas. So here we are finding the columns which are numerical, because variance you cannot find for categorical values or string values. It's a mathematical operation. So we are finding the variance. So for column in this numerical column, so all the columns which have numerical values, if their variance is a pandas function which is give you the variance of that column. If that variance is less than what our threshold is our limit is, that means we are going to keep it. So that is what we are doing here. So we need some amount of variance, and we want the data to be different. And if it all the data is same, we would want to drop it. So here low variance columns are those which are less than threshold, and data frame dot drop. We are dropping them, and in place is true. Basically, we are just ensuring that the indexes are not messed up after dropping these values. That's it. Any question in this?
Uh, I may be confused here for a bit, but we are
Okay. The
we are dropping
hmm,
the data which has variance less
less
than the
variance.
threshold data,
Correct.
like the threshold variance. Okay, but like, isn't threshold supposed to mean something like a maximum? So like whatever is
No, threshold is basically any limit. So threshold we are having here is a minimum threshold. So it should meet that value for us to. It's not a limit, but more of a minimum value. Over here, we are taking the threshold is it should pass this benchmark for it to, be having enough variance for us to consider. So maybe the name is as such, but threshold meaning it should reach this minimum value. You must reach this bar, and anything which is below this we do not want to consider.
okay. And if at all we
Yes.
are if at all we are not considering that, then
Hmm.
why have we given a parameter of in place equals true? Because we are anyway dropping it. So
We are dropping it. So basically what the in place is equal to true is not really changing the after dropping, you're basically making it reformatting the data frame so that there is no other after dropping we don't have any other issues. But I didn't get the question on why we are to reframe your question. Like I didn't get you.
I think my question was, if at all we are
Yeah.
dropping the
Hmm.
the data which does not meet
Hmm.
our criteria,
Yeah.
then why should we give a parameter called in place equals true to the data which we are dropping? Because we are anyway not going to deal with that.
Oh no, basically after we drop, we want in place equal to true so that this is automatically updated here. That's it.
Okay, so the in place equals true applies
Yeah.
to whatever is
The
left
data
after
directly.
dropping.
No, basically after dropping, do you want a new data frame or do you want to do it in place? So on this existing data, so it won't return a copy.
All right, all right.
So basically in place equal to true. If I don't have this field, it is going to give me a data frame. So, but this data frame is actually not what is modified. So I would have to give it as df is equal to df.drop.
Right, right, right.
So that's all you're changing here, nothing much. Next
Okay, I
is,
see.
no problem. Next is correlation analysis. Basically, when you're finding features which are highly correlated, you would want to remove them. So, for example, you would do this, you would find out these features when you're doing EDA. I think you have already gone through the EDA session, and well, correlated features are basically something which one variable is dependent on the other, like, and there's a strong correlation. So, let's say here we just had join date, or let's say join date as the feature, and work. Then the other thing, maybe we have also having time at the company. So you have two features, and maybe date of birth and age. These are two features in which you do not need both features. Either your age is sufficient or your date of birth is sufficient, and generally we keep age. So if you take their date of birth and their age, is that's in your data set for some reason. These are features which are highly correlated, but removing one does not really affect the data in any way, shape, or form. So you would want to drop one of them. So maybe we have dropped the date of birth and just kept the age. So this is what you would try to figure out in the EDA process if there are any features which are highly correlated. Next is model-based selection. There are some machine learning models which basically give you for a target variable. So let's say I have given performance score as my target variable. It would give me the list of features which are actually important. So that is what is generally done using decision trees. These decision trees are a common model in which it gives you the feature importance. So how much does each feature matter in the selection of the categorical value, in which case, which is performance over here. It is basically technically a categorical value from 1 to 5. So people who are belonging can belong from 1 to 5. So what all features affect in what way? I think when you learn further machine learning models, you're going to learn how to do this using these models. But right now, that's out of scope. I'm just giving you the theory behind it. So each model would give you the feature importance after training. So maybe you can train a basic model with the part of the data instead of giving the whole data, because it would take too much time. So you would just select maybe, let's say, 1% or 10% of the data with a large diversity. You're going to train the model with the 10% data, see which all features are actually important, and then drop the features which are less important, so that we are not wasting time training the model on those features. So this is what you can do when you're doing model selection. That is it for feature selection. Next will be data transformation. Any questions in this?
No.
Okay. Next is data transformation. So that what data transformation do is scale. What we commonly do is scaling and normalization, and what we are doing is so that each feature is basically belonging to a certain range. Basically, when we are dealing with something, let's say, is salary. Salary can be as maybe, let's say, from 10,000 to 1 lakh. This range is too much, in which the small, like, difference in amount, let's say here 69,000, 63,000, 40,000, 80,000. Okay, fine. But when there are suddenly also values like 10,000, 3,000, 5,000, these values are on a very large scale. So the value difference is huge. So there is 100,000 different values that can be in your salary field if you take the range. Whereas we might not really care about it. Like the 69,000 and 63,000, most of the times we not care. We consider it as 60,000. Okay, we have somewhere around 60,000 or somewhere around 70,000. So maybe only the first two digits are important here. These are the times in which we are going to scale the data. So what scaling does is it fixes a range and applies a new range on the data based on what is the existing range. It will scale it down. So first is min-max scaling. So like I said, maybe your range is from 10,000 to 100,000. So your lowest value is 10,000, highest value is 100,000. What we are doing here is mapping that value range from 10,000 would be 0 and 100,000 would be 1, and all the values in between lie somewhere between 0 and 1. So we are basically scaling it by dividing these values into so basically it will be 100,000 minus 10,000 divided by 100,000 again. So you're going to get the value between 0 and 1. This is something similar. The next is standardization. So, like I told in Z-score, what we are doing is basically creating it. Z-score is also one method of standardization in which we are centering the data around a mean value. So when we take a mean value, let's say between this, 50,000 is our mean value for that same example, you would see how far away this the features or the values are moving from 50,000. So 50,000 would be 0 and standard deviation as 1. So if something the deviation is 50,000, so 50,000 to 100,000. So that would be 0 to 1, and 10,000 to 50,000 would be from -1 to 0. Here you're mapping the range from -1 to 1 instead of 0 to 1. But Z-score is more better used for normal distribution, in which case there is a regular distribution pattern in the data. Next is log transformation, which is used in highly skewed data, in which case the number of these numbers are drastically increasing in a logarithmic or exponential fashion. When we use log-based transformation, it also scales exponentially, so you're going to get a value between getting constant value. After finally is feature engineering, in which we are making new features based on existing features. So first, let me explain. Here, this is min-max scaling, in which we are creating a min-max scaler. This is a Python object function or Python object in which we are performing same fit transform. So what we are doing, we are fitting it between the minimum and maximum, and we are transforming this existing data set. So here we can see after performing this, the salary value, all the values in this field will basically be between 0 and 1. So the maximum value would be given as, there will be one value which will be taken as 1 and one value which would be 0, and all the other values would be lying in between. Same thing is happening here for in the case of work experience as well. We are giving it as 1. So the highest work experience here we can see is 1, and the lowest work experience is being given as 0. So that is what min-max scaling is. We can also use Z-score transformation, but I think min-max scaling is standard scaling. We start using Z-score here. This is for Z-score, and min-max scaling is for the min-max transformation. Next is log transformation. So in the case where the log transformation, the values are highly skewed, in which most of the values are starting from 1,000, 2,000, 3,000, and there are also values such as suddenly jumping to 1 lakh or 100,000. These cases, you would use log transformation. You would basically still bring down to 0 to 1 without diminishing the other features. So, like I said, when we have something like 1,000 and 100,000 and you apply min-max scaling, something like 90,000 would be zero point 0.9, but something like 1,000 would just be 0.001. In that case, most of the time, the 0.001 will not be considered or would not be considered as a highly valued feature, even though it might be. So these are cases where you would apply log transformation. So based on their logarithmic value, you're not going to there's not going to be a vast difference in the fields values. So we're just applying NP is basically numpy. It's a numpy for function for basically log, and then we are applying it and on each of these fields. And finally, we are doing feature engineering. So let's say here I've just taken an example of experience per year. So based on how much you have worked, compared to how much what your actual age is. So your work experience compared to your actual age. Maybe this is useful in some metrics. So let's say how much work you have done. When you're comparing two individuals, this feature can be used instead of direct work experience. So you're thinking of, let's say, God forsake, but you do not. You're being someone is being checked on for a promotion. You would want to see which person has actually worked more compared to the amount of time they have actually been there. So maybe you can instead take uh, this years at the company. So instead of age, you're taking years at the company. So how long have they worked for, and compared to that, how much have they actually worked? So if they have worked for a long time and they have a lot of work experience in a short amount of time, you would think that they would be a better candidate suited for better positions. That is what feature engineering is. You're basically combining two or more features into a new feature, and you would generally drop the existing features. So if you're doing this, what we're doing right here, work experience and age, we are going to drop these two columns because we have something which is a combination of these two features, which is performing the basically the same task as having both of them at once. So we are reducing the number of features while keeping the same amount of information or similar amount of information. Why this is important is machine learning models take a lot of time when there is too much data. Here it's just 5,000 rows, so most of our data is being processed instantly. But real time data, let's say you're having 1 lakh rows, 5 lakh rows, it will take a lot of time, especially when you have a lot of features. Let's say you have 25 features and 5 lakh rows. It will take too much time to learn things from this. So what we are doing in this transformation is trying to make the job for the machine learning model as simple as possible. So that is mainly the role of data transformation. We are reducing the number of the digits the model has to look through. It's basically the numbers are between 0 and 1 instead of 1 and 100,000, because floating point precision would have been applied even if the numbers were integers, but the range would be 100,000, whereas here it's just between 0 and 1. And by feature engineering, we are removing the features which can be combined. We are combining them and dropping the instead of two features, it's just one feature. Maybe you have combined more than two features. That is what feature engineering does, where you are combining multiple features with while keeping the same amount of information as having both the features. So that's it for feature engineering. Any questions, guys? This is basically the end of the session, and comparatively, we have this is basically the clean data set. I'm just going to bring it up side by side and show you the differences here. So here is here. The one on the left side here is basically the the original data set, and right side here is the clean data set. So we can see the difference already. So we do not have this ID, we do not have this name column because these are not relevant for machine learning models. Next, we have made all the salaries as we have scaled the salary features down in a fixed range between 0 and 1 for easier training of models. Next, we have basically removed all these null values. So here we know there are 167 null values, whereas here there should be no null values. So this is basically the whole role of data wrangling, in which you are making the data set ready for a machine learning model. And these steps are basically general things you would apply for all types of data, but for specific models, there will be specific transformations and pre-processing which you might have to perform, which you would have to learn based case by case based on which model you are using. So that's it for this session, guys. If you have any questions from any of the sections, please ask me right now. Anyone, any questions?
Guys, please feel free to ask any questions or doubts. You can ask by unmuting yourself or asking in chat.
Yeah, you can also drop the message in chat if you have no issues. There will be, I will take time to answer. Maybe today, if you have any questions, you can also drop them. I can check them and answer to you guys. Just drop them in the group itself so everybody can see the question, and maybe I can answer it for everybody. So if you don't feel like asking now, or maybe you want to try your own codes, you can try. And if you have any questions by today or maybe tomorrow, you can just drop them in chat so I can check them and answer your queries.
Guys, this part of the bootcamp is very important because this is what will help you to make models in the next module. It is very important you learn and understand what is happening and how you're going to do it. So I would really suggest you go through the code and document and try doing the assignment yourself rather than asking ChatGPT, because it will be a huge learning experience for you when you do it yourself.
Correct. Basically, all the first three modules are basically things you're going to do for any machine learning project you take up. You would have to perform all this. You would want to do EDA, you would want to do data cleaning on almost any data set you find. You cannot just blindly use it. So you would at least do a basic level of inspection. So these are things you would do for all the data you're going to encounter. Maybe you won't apply all the models, but these are things you're going to use throughout your machine learning journey. So it would be great if you could, try out all these things, and maybe you can explore even more further. And if you have any doubts, even outside of what I thought, but something related to this data cleaning or pre-processing, please let me know or just drop the question.
Anyone wants to ask any doubts, any suggestions, anything?
Okay,
Okay,
I guess it will be better if people, run the code and maybe then they'll get more doubts. So I think we can end this for now.
okay, guys. A very nice and informative session by Shriyasha. Thank you all of you for attending. Good evening.
Thank, thank you, guys.
Thanks.